Like all living animals, you need enzymes. You have many different processes going on at the same time. You may be digesting food, you may be running out in a park, but those processes may take forever if it weren't for enzymes. Enzymes are things in your body that help speed up processes, help catalyzation, which allows many different processes to occur that may take days to occur in a couple of minutes or hours. But rarely any people begin to think the true process and structure that goes into an enzyme. A simple drawing of an enzyme would be a little circle with an active site. This active site is where catalyzation begins to start, or where you activate the enzyme. How do you activate the enzyme, you may say? Well, with a substrate. This is the substrate. So what begins to happen is that the substrate, so what happens whenever a substrate goes and whenever a substrate begins, it so sorry. Whenever a substrate comes in contact with the active site of an enzyme, it begins catalyzation. It tells, for example, if this were lactase, this substrate would kickstart lactase and kickstart the process in which lactose is digested, which is why lactose intolerant are people without the enzyme lactase. They are unable to process lactose and stuff like that. So another site that another site that is present in the enzyme is the allosteric site. In here, in the allosteric site, any any different type of substrate, different types of whatever, can go into this tiny little pocket and inhibit the enzyme or denature it. Denaturing is the process in which um, an enzyme is not able to work because of different conditions. It could be conditions like heat, or it could be conditions like, of course, like I've said before, coming in contact with the allosteric site, inhibiting the active site and not allowing the substrate to enter. Whenever the substrate isn't allowed to enter, or if the shape of the active site is changed, the substrate won't be able to interact. Whenever the substrate isn't allowed to interact, it can't begin the catalyzation, it can't begin the process of the enzyme, and the enzyme doesn't work. It's denatured, it slows down or just stops working altogether. After, but if you successfully catalyze, if the substrate if the substrate successfully goes into the if the substrate goes successfully into the active site and does the catalyzation, it will break apart and form two different things. Not two different things. It will form a product. A product is what breaks off of the active site after catalyzation has. Like I've stated before, the process of an enzyme is to speed up chemical processes that may take a while previously. But it's also to conserve energy. In a graph from Khan Academy, it shows us the different types of energy usages based on if an enzyme is being used or not. Products right here, reactants, of different varieties, reactants of different levels. This is the non-catalyzed, and this is the catalyzed. And this is energy usage, and this is the progress. As you can see by the graph, the reactant that used a catalyzation, that used an enzyme, not only finished faster and quicker, but it also used way less energy than one without an uncatalyzed reaction. This is due to increasing efficiency and the effectiveness of chemical reactions that previously wouldn't been able to have occurred due to not having an enzyme, due to not having a product to speed it up. Now, for example, let's look at an enzyme, pepsin. Pepsin, like any other enzyme, has an allosteric site, an active site, and different types of things. Of course, a substrate binds with the active site, in order to kickstart catalyzation. Now, what does Pepsin, sorry. This is pepsin. Now, pepsin is an enzyme that is used to break down proteins into smaller peptides or amino acids in the stomach. We need this because if we didn't have an enzyme that would be able to break down these pepsins that would be able to break down these proteins into smaller amino acids, the process would take a while. We would be fuller for a while. We wouldn't get as much energy in as we could have. We won't be able to digest as many proteins as we could have without the use of the enzyme. But because of this enzyme, our body is able to efficiently digest many different types of enzymes, allowing us to survive and allowing us to be self-sufficient.